Here's a circuit. We got 32 volts, and we've got R1 and R2, 10 ohms, 6 ohms, and here's R3 is 8 ohms. And we want to know all this stuff about this circuit. The resistance through here, the total resistance of the circuit, the current through these guys, the current through this guy, the voltage across each resistor, and the total current in the circuit, and in no particular order. Then we'll answer the questions, what makes R1 and R2 in series, and what makes R12, the combined resistor here, in parallel with R3. And if you know how to do all this, you should do fine on the quiz. So let's solve it. So what is R1 and 2? Well, and actually I'm going to answer a part B. I'm just going to say it rather than write it. But what makes these two guys in series is that there can be only one current through the two of them, right? If you've got, let's say the current is 2 amps or something like that. If I've got 2 coulombs per second flowing through this resistor, that current has no choice but to go through the other resistor. They must, the current must go through them. There are no branches of wire coming, between them or anything. So that's what makes resistors in series. They have the same current. Okay. So, and when you have resistors in series, you know to add them. So that's going to be 10 ohms plus 6 ohms, 16 ohms. Now, on the quiz, I'm going to grade this by saying, did you get the right answer with units? That's a point. Did you show how you got your work? That's a point. So don't do it in your head, some of you who have good mental math skills. Show me how you did it. Max, wake up. Max is asleep. I am recording this, so Max is now. Okay, now, let's get the total resistance. Well, the total resistance is, well, this is in parallel. The combined resistance over here is in parallel with this. So you could, if you want, you could redraw the circuit like this. And you say, okay, R1 and 2 together is 16 ohms. And then this is 8 ohms. And you would say, okay, these are in parallel. So the equation for resistors in parallel is 1 over R1 and 2 combined plus 1 over R3 equals 1 over, now watch this. This is 16 ohms. Look where I put the ohms. I put the ohms in the denominator of this little fraction right here. That's where it belongs. Okay, plus 1 over 8 ohms. Now, I try to write these problems so that you don't really need your calculator. I think I did that on the quiz. Actually, I haven't written the key yet. So, so this is 1 over, well, let's do this. Let's just do this. Need a common denominator. This is 2 over 16. And 2 over 16, 1 plus 2 is 3 over 16 ohms. Reciprocate and multiply. That's going to be 16 ohms divided by 3. And geez, what is that? That's, what is it? 5.33. 5 and 1/3. And that's going to be ohms. So that's the total resistance, turns out to be 5.33 ohms. And look, this, and remember, to find the total resistance, if you're doing resistors in parallel, the equivalent resistance is less than the smallest resistor. So here we had the equivalent of a 16 ohm resistor and an 8, and you got 5.33. So you know, hey, it's smaller than this one, so we're probably okay. Now, I12. Well, we know that V equals IR, and that's true for the whole circuit, and it's true for any combination of resistors or any individual resistor. So here we have a combination of resistor, 1, 2. So I equals V over R. And we know what the voltage is. From here to here, it's 32 volts. And we're going to divide that by R12. R12 is 16 ohms. 32 divided by 16 is 2. And what do you get when you divide a volt by an ohm? Well, an ohm is a volt per amp. So the volts cancel, you get 1 over amps, which is amps. Of course, current is measured in amps. So we got this one, this one, this one. And by the way, on the quiz, I don't care if you do them in the right order. I'm doing these in order, but you don't have to do them in order. Do them as you think of how to do it. Now, what is I3? I3 is equal to the voltage for 3 over R3. Well, what's the voltage across here? Oh, it's just 32 volts divided by 8 ohms. Oh, we're going to have 4 amps going through there.
That's 4 ohms.
I mean, oops, thank you. I was just testing you. And you passed. Good job. All right, so I'll get it right. All right, it's early and I haven't had enough coffee yet. All right, now V1 and V2. This one takes a little work. V1 is equal to I1 times R1, right? And what is I1? It's 2 amps because I1, 2, these are in series, so they have the same current. So this is going to be 2 amps times 10 ohms. So that's going to be 20 volts. V2 is going to be I2, R2. But I2, what is the current through I2? 2 amps. Does everybody see that? Any questions? Okay. And that's 6 ohms. So that's 12 volts. And what do you notice about these two voltages? 20 volts and 12 volts. Here we have a 20 volt drop, and here we have a 12 volt drop. Does that give me 32 volts? Yeah, sure does, because look, the battery gives me 32 volts. If I'm going to go from 32 volts to 0, I better drop. These two share the voltage. They've got 32 volts to share. Resistors in series share the voltage. So they got 32 volts, so 20 plus 12 is 32. Yay. Make sense? Okay. Yes, Roman. Or Ron. What?
Each of them have 32 volts?
No. Well, this one does. Just think, okay, everything up here is at 32 volts. Everything down here is at 0. And just think of like dropping down. Now, this one, when you go from here to here, you drop 32 volts, right? So, yeah, R3 has 32 volts across it. So it's going to be I3 times, well, actually, I don't even need to do that. V3 is equal to 32 volts. Now, I can check my work. Oh, well, I just used this to get that, so it's kind of redundant. Do you see that? So now this, if you go from 32 to 0, look, if a lot of students will do this. Let's say you put 32 volts right here. If you put 32 volts right here, 32 plus 32 is 64 volts. Now all of a sudden, You got too many volts. You got more voltage drops than you have voltage gains. You're violating the conservation of energy when you do that. Because remember, volts is joules per coulomb of charge. And by the way, some people say, oh, these split up the voltage. So they'll go 16 and 16. But that's wrong. When would it be 16 volts and 16 volts? Yeah, if they are equal resistors. But here they're not equal resistors, so they're going to have a different voltage. Okay? Now, where are we? So 1, 2, 3. What's the total current? There's a couple ways to do it. The total current, that's a current that flows through here. Well, look, I've got a current that flows through here and a current that flows through here. What is this? This is the current that flows through 1 and 2. This is the current that flows through resistor 3. This is the current this is the total current delivered to the circuit by the battery. So what do you think is going to be true about this compared to these? Anybody want to volunteer? Charge coming in has to equal the charge coming out. How much charge is coming out? Well, there's this one is 2 amps, and this one is 4 amps. So 2 coulombs per second out here, 4 coulombs per second there. How many coulombs per second are coming out? 6. So how many have to be coming in? 6. You just add up the currents. Whenever you have a junction, this is called a junction, the current coming in has to equal the current coming out. Otherwise, you're creating charge from nothing, or charge is disappearing from the universe. Not possible. So the total current is equal to 2 amps plus 4 amps equals 6 amps. Now another way to check it is to say, well, V equals IR for the whole circuit. So I, the current, is equal to the total voltage divided by the total resistance. And if you take the total voltage, which is 32 volts, divided by the total resistance, which is 5.33, if you divide that, you will get 6. You can plug that in your calculator and say, I think it's probably like 5.999 or something like that. But what do you get?
6.
Yeah, you get 6. Yeah. Okay? Either way will work. I'll accept either method for figuring out the total current. Let me out so you can see the whole thing. So it's kind of a lot of work. All right. Any questions? Okay, that is all.